session on uh, addition of positive numbers. As we have seen in the previous session, how to add two positive numbers we have seen. This is the example what we are feeling interested here. 1 plus 1, if you add, it's actually 2, right? So 2 represented by 1 and 0. So this 1 is like your carry out and this 0 will be the sum. So this is what we discussed in the previous session about the addition of a one bit number. All right, now let us go into the details. How can we do the addition and subtraction of signed numbers? In case of unsigned numbers, we do it much more easily. And what in case of signed numbers, how do we do the addition of numbers? It's very simple. So what is this sign extension and what is this sign bit? Let us have an idea of that. And then we'll go forward with the addition of and subtraction in signed numbers. Okay. So we can relate addition and subtraction operations by numbers by the following relation. So it's like plus or minus a minus of plus b. That will give you indirectly plus or minus a plus of minus b. So that's how you can able to represent the numbers. We'll see that in much more detail now. You see this first diagram here. It's a modular number system and the two's complement system. So which one is modular number system? For two's complement system, the right side one B. The first one is what? Circle representation of integers of mod n. If you have n number of integers, we can represent that by using this method 0, 1, 2, 3, 4, 5, 6, 7 up to so on n minus 2 and n minus 1. Let us say capital N value is 8. We can represent this circle 0, 1, 2, 3, 4, 5, 6, 7 up to 8. 8 minus 2 it is 6. 8 minus 1 it is 7. So we can go up to that. All right. Now if the value of n is say 16, if the value of n is 16, in that case we represent from 0, 1, 2, 3, 4 so on up to 14, and n minus 1 is 16 minus 1 is 15. So this is how the general approach of representing the numbers in a circle representation. All right. And wherein if you look at this one, the right side one, we have mod 16 system. So what does this mod 16 system is going to do? So we are representing the numbers from 0, same as it like here. So 0, 1, 2, 3, 4, 5, 6, 7 up to this point. 0, half of them will be positive numbers and half will be negative numbers. As you have seen in the two's complement representation, how do we represent them in modular approach? So 0 is all 4 zeros, 1 is 0, 0, double 0, 1. And similarly 7 is 0 triple 1. So there is no confusion with this one representation 0 to 7. Wherein how we got minus 8. So minus 8 is what the representation of 7 in 2's complement form. If you take 7, it is 0 triple 1. Okay, if you represent that 7 in 1's complement, it will become 1 triple 0. All right, so that's what 1 triple 0 we got. Okay, and now you check this 7 and minus 7, you check these two, so we can able to spot out easily. So 0 triple 1 becomes 1 double 0 1, which means it's a 2's complement representation. Similarly 6 plus and minus is represented in 2's complement representation. The same as this what we have seen in the previous session, 2's complement representation. So this one, so this been represented here, and instead of representing the number, we have represented that along with its binary number. So that's how we represented here 2's complement number. Now let us try to do the addition and subtraction using 2's complement technique. How do we do the addition and subtraction using 2's complement technique? Let us see. To do addition or subtraction, we need two numbers. Let us try to take two numbers and we try to add them if both of them are represented by n bits. Let us say first number is 4 bit, second number also is 4 bit. Let us assume and do the addition. And in this process, we are trying to ignore the carry out what we are going to get in the MSB position. That is not significant here. We are trying to carry out that without considering the MSB of this carry out. Now, the sum will be algebraically correct value in 2's complement representation, as long as the answer is ranging from minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. So which means this is going to tell you the range of this. So this is the complete range of this. So the number, if you do it, it should be within the range. That's what the point we are trying to make it here. It should be in the range of minus 2 power n minus 1. Let us say the value of n is 2. What is 2 power 2 minus 1? 2 power 2 minus 1. 2 minus 1 is 1. 2 power 1. So it's minus 2 is the maximum negative number what we can have for 2 bits. And if the same positive number if you take here, it is 2 power n minus 1, which means 2 power 2 minus 1 is 2 power 1. So we can have 2 power 1 is 2 minus 1 will be 1. So that's how minus 2 to 1 is the numbers we have. Minus 2, minus 1, 0 and 1. Because 2 is the power of n, let us say 2 square will be 2 power 2 will be 4. 4 numbers only we can represent. So what are the 4 numbers? Minus 2, minus 1, 0 and 1. So that's how this works. Now, if you want to subtract two numbers, let us say we have two numbers x and y. If you want to subtract them, which means it can be x minus y or it can be y minus x. Let us take if you want to perform x minus y. So from this 2's complement form, uh, what we have to do is we have to find the 2's complement of y and then add it to x. It gives you the subtraction. So how to do 2's complement of y? First you take y, perform the 1's complement of it and add it with 1 in the LSB, you get the 2's complement form. And you add x and y, you're going to get the subtracted value. It's an interesting part. If you do addition, we get subtraction. Nowhere we do subtraction here. Even though we are performing x minus y, we're not using any subtractor here. You can able to simply solve it by using only adders. Okay. And the range of this also will be same. It will be ranging from minus 2 power n minus 1 to 2 power n minus 1 minus 1. Let us take an example of that. If you are trying to add 4 and 3, there is both are positive numbers. There is no problem in this. So 4 is represented by 0, 1, 0, wherein 3 is represented by 0, 0, 1, 1. To directly add them, as we have seen the binary addition in this process here, based on this input what we have. If you have 0 and 0, sum is 0, 1, 0, sum is 1, 0, 1, sum is 1, and 1, 1, the sum is 0 and the carry is 1. With this input, let us carry forward. Let us look forward to do that. So we know that 4 plus 3 will give us 7 in decimal form. Let us check that with binary form. So 0 and 1 from the above table, what we have, 0 and 1, if you do, it's 1, 0 and 1, it's 1, 1 and 0, it's 1, 0 and 0, it is 0. So plus 7 we get 0 triple 1. So this way we can able to represent plus 7. So the simple thing we can able to understand, it's clear for us. Now what about this condition, minus 4 and minus 3? If you want to add, both of them are minus. So minus 4 means what? The MSB bit is going to have 1 here. That's the only difference. Similarly, minus 3, the MSB bit is 1. That's the only difference. Now you should do the sum of them. 0 and 1, it's 1. 0 and 0, it's 0. 1 and 1, it's 0. And the sum is 1. 1 and 1, it's 0. Carry is 1 again. And that way we're going to get 2 1s here. So this 1 is going to represent that it's a negative sign. And 1 0 0 1 is the form of minus 7. Okay. So that way we are going to do the simple addition by using carry in, and we are neglecting here the carry out what we are going to get. Correct? So that way we are trying to do it. If the carry in is high order, then carry out, then ignore the carry. If we are getting, see, if we are trying to do 4-bit addition, we are getting the 5th bit. What does it says? Ignore this carry. If carry in differs from carry out, then we have overflow. Carry in differs from carry out. What carry input we are trying to give, if that is differing, we can able to say that we got an overflow condition. So this is an interesting topic. So I have given the mini project on this. How do we analyze the, you also can do the mini project on this. How do we analyze the overflow and underflow condition? So it's an interesting part if you take the sign numbers. Okay, so simple interesting addition schemes can be done by using 2's complement methods, and you can have some sort of interaction during the next sessions with the tutorials. That will be much more easier for you to understand the representation of those complement numbers. You have a lot of numbers here. You can look over this. and you can able to analyze this. You can take a screenshot of these numbers and try to solve it. So any other doubts, you can put it in the chat box. Thank you. With this session, I'm going to end up the representation of two component numbers, addition and subtraction. Thank you. See you in the next session.